Next problem is called product of array except self. We are given an integer array in nums, and we have to return an array answer such that each element in the answer is equal to the product of all elements of nums except for that element. The product of any prefix and suffix of nums is guaranteed to fit in a 32-bit integer. We have to write an algorithm that runs in linear time and without using the division operation. So this is an important note, without using division operation, because if we could use division operation, we would just multiply all the numbers and then just iterate over every number and divide the total product by that number. And so that would be a straightforward solution, but we cannot use division operation. In the first example, we have 1, 2, 3, 4. And so for the first number, we have the product 24. That's because 2 times 3 times 4 is equal to 24. For the second number, we have 3 times 4, which is equal to 12. For the third number, we have 2 times 4, which is equal to 8. And for the fourth number, we have 1 times 2, 1 times 3, which is equal to 6, which is our last number in the result. For the second example, it basically follows the same logic. Because we have a 0, it will cancel out every product except for that one that all other numbers form this when we exclude the number 0, which in this case is just -1 times 1 times -3 times 3. We have 1 minus 1, which is basically -1 times -3, which is 3, and then we have 3 times 3, which is equal to 9. The length of the array is ranging from 2 to 10 to the 5th, and the elements in the array are ranging from -30 to 30. And the product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. We also have a follow-up. We have to solve the problem in constant space complexity. The output array doesn't count to. We can exclude it from the calculation for the total space complexity. Now, the solution to this problem is actually in the problem statement. It says prefix or suffix of nums. How can we use a prefix or suffix, or prefix product or suffix product to solve this problem? We'll go through an example. So let us just, we are given the same example from the problem statement. So the prefix product of any, so prefix product of element that corresponds to the index I is basically all the numbers starting from 0. So this is the initial array. So I just actually call it initial array just to remove the confusion. So it will be array first element of the array times the second element of the array times all the way up to the element just before the element we are calculating the prefix product of, and that's basically it. That's the prefix product. The suffix product is just the other way around. So for the suffix product, we have of I is basically array starting from the number just after the index we are calculating the suffix number 4 multiplied by +2 and so on until we reach the last element of the array. So how can we use this to solve the problem? But you can see that the prefix product for every index of the original array is all the numbers, the product of all the numbers before the number that corresponds to that index, and suffix number, all the numbers after it. So the only number that's missing is actually the number that we are calculating the suffix product and prefix product for, which basically means that we can get the product, the total product, by multiplying the prefix product and suffix product of an element. And that will be the total product when we exclude that element that we are using the prefix and suffix product for. Say we have this is our array, and for multiplication, the neutral element is 1. So we'll start with 1. So to get the product, we will first calculate the prefix product, then the suffix product. And so we will declare our array result and we will just go over the elements from left to right and calculate the prefix product. So the result array will just, for the first iteration, it will contain only the prefix product. So basically for the first element, we will have the current product, which is 1. For the second element, we will have the current product, and then we will, once we are done with the first element, we will multiply our current product by it, but it will remain the same because we have the element 1 as the first element. So the prefix product of number 2 will be again 2. And then we multiply our product by 2, so it will be 2. And then for the next element, the prefix product will be 2. And then we will multiply again by the current number, which is 3, our product, and it will become 6. So for the last element, we have the prefix product equal to 6. Now we go the other way around and we reset our product to 1, and we calculate the suffix product. So we will start by 1. We will start with 1, and then so it will be for the last element, it will be whatever we have as a current value, which is the prefix product. So we will just copy it over, and we will multiply our current product by the current number, which is 4. So it will become 4. Now for this element, for the next element 3, we will just multiply its current prefix product by the current product that we have, which is basically 8, and we will multiply our product by 3, which will become 12. So for the next element, we will basically put 12, and that's our number 2. So we'll multiply by 2. Our product will become 24, and for the next element, we will just write our current product, which is 24. And because we are at the beginning of our array, we are done with the iteration. And as you can see, we calculated the same product excluding for each element, excluding that element, by using the postfix and suffix product. And because we are only traversing through the array twice, we are only using n linear time complexity proportional to the length of the array, while for the space complexity, we only have this output, which doesn't count, as we don't include it in the total computation that we need. So the space complexity will be constant. We will first start by declaring our output array called result, which has the same length as our input array. Then we will declare the neutral element for multiplication, which is 1. We will set that value to our current prefix product that we are calculating. We will iterate over the elements left to right. Each time we will put the current prefix product that we have for the current number in the output array, and we will multiply the current product by the number that we are currently iterating over. So that next element that we will calculating the prefix product for will contain the effect of the previous element. Next, we will reset the product to 1 because we are calculating the suffix product, and we will start from right and all the way to the first element, each time applying the current prefix product that we have with the current product to get the total product of prefix product and suffix product, so excluding that number that we are calculating the prefix product and suffix product for. And then we will just multiply, as in the first iteration, we'll multiply the product by the current number. Now, at the end, we will just return the result array that we declared in the beginning of the solution.